How to cook the reals. We usually take numbers as a given, but it is possible to mathematically construct them from basic set theory. Every construction in that diagram is fairly easy except these two. I want to focus on that one. So, assuming you have the set of rationals with all its usual operations of addition, multiplication, and so on, can we make something up that behaves like how we think of reals? There's many ways to do this. I will explain one particular way. So take a real number, say pi, and let's say you want to tell someone that you are thinking of pi but using only rationals. So well, you could just say 3, 3.1, 3.14, and so on, and the other person will know exactly which number you are talking about. We say the sequence because we know that the sequence converges to pi. So done, we can define R to be the set of all convergent sequences from rationals. So pi is the sequence, root 2 is the sequence, 5 is the sequence. But hold on, this sequence actually does not converge in Q because its limit is not in Q. This is very strange. It feels like it's getting close to some number, but that number doesn't exist. This is different from, say, this sequence, which clearly doesn't feel like it's converging. So, is there a way to differentiate between these two sequences without using their limits of convergence? Notice how the terms in this sequence get close to each other as you go ahead in the sequence, which is not the case for this sequence. Such sequences are said to be cauchy. A cauchy sequence is a sequence in which the terms get arbitrarily close to each other as n goes to infinity. So just replace that with cauchy and we are done. Also, how do we define addition and multiplication on real numbers? It turns out that when you add or multiply two sequences term-wise, the n sequence is also cauchy and it aligns with the number that we expect to get.